Hey, good morning, everybody. This is Mr. Ainsworth here in pre-calc in Unit 4. Okay, our first lesson in Unit 4, 4.1. Here we go. Let's read the context. Mallory is training for a race here. She plans to slowly increase her race during the month of July. That's a good idea. I used to run. And on July 1st, she starts running 15 minutes. Okay, you note that in the table right there. And then she adds 5 minutes to a run every day, and that's right there is the rate of change. Okay, rate of change is equal to 5 minutes, all right, per day, all right, increase. Starting off with the first right here, the initial time of 15 minutes, you can see that. All right, so Mallory tries to record how much she ran every day, but she notices that she forgot to keep track of her running on several days. Complete the running log for the indicated days. All right, so here we go. And before we get started here, this is obviously we're looking at the bigger picture. We're going to be dealing with arithmetic sequences here, and sequences of numbers that deal with some kind of addition. In this case, we're adding 5 minutes to a run every day. So this is actually a lesson on what's called arithmetic sequences, which in last year you guys started discussing this. Okay, so but they probably didn't put it in a context like we're going to do. So today, inside this lesson is arithmetic sequences, and we want to figure out our arithmetic sequence formula here through looking at a situation in context. To do that, we need to base everything upon the first day, which is July 1st. So before we get started here, write down in red, okay, base all calculations, calculations on the first day. And you'll see why here in a minute. Okay, so just make that a note, which is, in this case, July 1st, okay, first day. So everything is based upon this. And there's different ways of doing this, but again, I'm trying to get to the bigger picture here. And so in order to get the bigger picture, you got to look at patterns. And to do that, we want to base everything on the first day, July 1st. Okay, here we go. Just notice I put that in the wrong spot. So here, put down here, July 1st, first day, okay, of the month. All right, now she started off with 15 minutes run, and then the next day, July 2nd, all right, she runs 5 minutes more. So put down method here, okay, so 15 plus 1 day at 5 minutes. So 5 minutes times the number of days times 1, 5 days times 1. Actually, let me reverse the order there. So 5 minutes per day, 5 minutes per day, all right, times the number of days, which is 1 day. From the first to the second is 1 day. Okay, now if you take a look at it, 5 times 1 is 5 plus 15, and that is 20 total minutes, okay, on the second day. So when you're using the rate of change here, think simple. The rate of change, minutes per day, all right, times the number of days gives you total time. In fact, you know what, let's go off to the side and let's write down that key concept. Okay, so total time in this situation is, or the total increase in time, is equal to your rate of change here, all right, times the number of days. So times number of days, all right, past the first. So in this case, we got 5 minutes, all right, per day, all right, times the number of days, 1 day. And if you notice that the units cancel out nicely, and we get a total 5 minutes added to that. And I know the numbers are completely simple, but that's the key idea. All right, now we're going to base everything on the first day. So I'm going to just do one more, and then I'm going to put you guys up on the boards if you're in class to figure out the rest of the time on any given day of the month, but always base calculations on the first day. So for example, to go from the 1st to the 5th, that's 4 days. Okay, 4 days right there. All right, and because of that, we have an increase, or we can calculate the total time by the following. We're going to take the initial time, the first day, 15 minutes, but going from the 1st to the 5th, that's 4 days worth of increase, and so we're going to take 5 minutes per day, 5 minutes times 4 days, and that's 20 plus the original 15, and now we're up to 35 minutes total. So you take the minutes per day, the rate of change, and multiply it by the number of days that we're dealing with, in this case, 4 days. So again, how do you get to the 16th day? Well, to go from the 1st to the 16th, All right, that's an increase of 15 days. And each day of the 15, you're going to increase your run length by 5 minutes. So to calculate that, we're going to take 15 times 5 minutes per day times the number of days, which is 15. Okay, and then you multiply 5 times 15 is 75, plus 15, that's 90 minutes total on that particular day, July 16th. And then you keep on using the same strategy. So if from the first here, again, you always base it on the first, from the first to the 30th, first to the 30th right there, that's a change of 29 days right there. 1 plus 29 is 30. All right, so to base it on the first day, we're going to take 15 plus 5 minutes per day times 29 days, and that's going to give us, let me see, 5 times 20 is 100, 5 times 9 is 45, so it's 145, plus 15, that's 160 minutes total, okay, on July 30th. Okay, and then what do we have? And so on July 31st, she already wrote down that she ran 165 minutes, which makes sense because if you simply add 5 minutes to 165, because the rate of change is 5, right there, you 160 plus 5 is 165, so that makes sense. Give a little happy face right there. Okay. Now it says write a rule. Write a rule, a function rule that gives the amount of time Mallory runs on the nth day of July. Okay, so in terms of n. So basically we want to say, okay, given the nth day, all right, what would her function be? What would the rule or function be to calculate the minutes, total minutes? So what we want to do is, obviously develop a function. And since we're dealing with time, let's call it time spent around. Let's call it t of n. So function notation right there, t of n. So t of n is equal to what? Okay, so to understand that, we want to base everything, or we actually have to define n. Okay, so what's n? Well, July 1st, let's consider that n equals 1. July 2nd, n equals 2. July 5th, n equals 5. So July 16th, n equals 16, and so on. July 30th, n equals 30th. But what would the function be to describe or calculate the number of minutes total that she runs on any given day, where n corresponds to the day number, okay, during the month of July? So n equals day number, okay, in July. What would that be? Well, we got to take a look at patterns. We know it's got to be 15 plus something. So 15 plus something, and it's going to be 15 plus 5 times something. So 5 times something. So what is that something? Well, what we want to do is consider and compare the following. So when n equals 2, it's 15 plus 5 times 1, okay? And then when n is 5, it's 15 plus 5 times 4, okay? We're talking about the number of days past or since July. So we have to modify this. So it's not 15 times n because if you take a look at it here, let's compare. On July 2nd here, for n equals 2, if you compare, whoops, let's not do that. When you compare n equals 2 to the number of days after July 1st, you notice it's 5 times 1, not 5 times 2. So, and then here, for July 5th, it's 15 plus, not 5 times 5, all right, but 5 times 1 less than 5, or 5 minus 1. So the number of days, after July 1st is always 1 less than the month number. So we're going to multiply this by n minus 1. Okay, and then it says show that your rule works. Okay, so actually before we do that though, let's simplify a little bit. So let's distribute through the 5. So 5n minus 5, 50 minus 5 is 10, so 10 plus 5n. Okay, so let's show that it works. Let's pick a month. Okay, so let's do July 5th. So July 5th, that means n equals 5. So let's find t of 5. And that's going to be 15, excuse me, let's use the end result here. Down here at the bottom, 10 plus 5n. Okay, so we have 10 plus 5 times 5, and that's 10 plus 25, or 75. What happened here? 5. What happened? 5, 5, and 2, 2, 2. Oh, that's not 75. What am I 10 plus 25. Come on, Ainsworth. I don't know what I was thinking. Back up. Okay, 10 plus 25 is 35. So 35 minutes total, and that makes sense because it's right up here. Okay, so it checks out. Now, in general here, where we want to interpret things here, so we're going to call 15 here, 15 minutes, your first term. And in sequence notation, that is called a sub 1. That represents your first term. So really what our function here is this first term plus 5, which is called the rate of change here. It's referred to as the rate of change, but in sequences here, that rate of change has another name. It's called the common difference. And it's denoted by d. Okay, we call it the rate of change, but in linear functions, and in sequences here, arithmetic sequences, is called the common difference d. So we have a sub 1 plus, all right, d, all right, times n minus 1. And in basically your sequence formula in general is called a sub n. So a sub n is equal to this. So let's write off in the margin here. A sub n is equal to your first term plus the common difference times n minus 1. Okay. And then, well, how do we use that? Okay. So this is dealing with arithmetic sequences. Okay, number 3. What was Mallory's average run length? Ooh, average run length during the month of July. How do you figure that out? Okay, so we got 31 months, and what would be the average? And so typically, though, when you're dealing with averages, you would add up all the times during the month of July, which would be 31 different times, and then to get an average, you would take that sum and you would divide it by 31. All right, but that we don't have every single one of 31 days, so how do you figure that out? So to understand that, let's go off to the side just for a second, and let's just modify or simplify the problem. So let's say, and then this is just simplifying it here so we can figure out how to do this. If we took a sequence of numbers from 1 through 5, let's say, and I asked you, what is the average of the first 5 counting numbers? What is the average of 1 plus 2 plus 3 plus 4 plus 5? So 1 plus 3 plus 4 plus 5. What would the average of all these numbers be? We would add them up and divide by 5 in this case. Okay, so to get an average, we would take the sum here and divide it by 5. Let me see, 1 plus 2 is 3, 6, and then 10 plus 5 is 15. So you take 15 divided by 5, and the average would be 3, which notice it's right here in the middle. All right, but how else can you get this average by only using the first and the last terms? Okay, the 1 and the 5. How can you get an average of 3, the middle number, by using your first term? This is your first term, and this is your last term. Well, you could do it by taking 1 and 5, adding them up, and dividing by 2. Okay, so another way to do that is by using your first and last term. So first plus last, divide that by 2. So in other words, we can take 1 plus 5, all right, divide that by 2, and that's 6 divided by 2, or 3, and there's your average. So basically, as a formula here, as an idea, you could take your first term a sub 1 plus your last one, which is called a sub n in general, all right, divide that by 2, and you'll get your average. So how do we do that for our problem that we're working on? Well, we take our first term, 15, so our average here is equal to 15, here's your first one, plus your last one, which is 165 minutes, divide that by 2, and it's 180 divided by 2, so we know the average is 90. Okay, now in the table, let's take a look at it. Where does that fall? Okay, and so 90 is right here. Okay, so 90 right there, it happens to be in the middle there. The 16th is the middle of all the data. It's called the median. So the average, which another name for that is the median, okay, which is a fancy way of saying middle number. Okay, and the 16th is in the middle of the month, right? So this right up here is the average time, runtime, average runtime. Okay, there we go. Okay, so we have some key ideas forming already. We know the arithmetic sequence formula. We know how to find the average of a sequence of terms with only using the first and last and not all of them, which is kind of nice. And then next major thing is how do you find the minutes total for the entire month? Okay, now without adding all 31 months together. Okay, so without adding the times for all 30 days, 31 days. How do you do this without adding all the times for all 31 days? And so what you do is you take the average, and if we know the average is 90 minutes for runtime, and we know there's 31 days, we could use that as our method here. So the total time, okay, for the entire month, which is the total sum, okay, so it's called a sum. Total time is the sum of all. It can be found by taking our average and multiply it by the number of days. And in general, it's by the number of terms in the sequence. All right, so let's do that. So we've got an average here of 90 minutes per day. 90 minutes per day multiplied by 31 days. Let me see, so then 90 times 31. Okay, so you get your handy dandy calculator here. So 90 times 31. Okay, and that's 2,790. Okay, so that's 2,790 minutes total runtime. Total runtime. There we go. So we have another key concept there. So far we're already up to like 3 major key concepts. We have the arithmetic sequence formula, which I should have put in red right here. So let's do that. Okay. Oh, forget that. Okay, we're on a little iPad issue there. So we have our arithmetic sequence formula. We have a way to find the average using first plus last divided by 2, and we have a total sum formula just by taking the average and multiplying it by the number of days, or in general, it is the number of terms in the sequence here. In this case, it's 1 through 30. 15 and then 20 and so on, all the way up to 165. Okay, now let's extend it here. Mallory's brother David also started training on July 1st. Okay, and he keeps track of the number of miles. Okay, instead of the number of minutes, he keeps track of the number of miles he ran. He adds 0.2 of a mile on his run. So each day, there is the rate of change. He adds 0.2 of a mile on his run. On July 18th, he runs for 7.6 miles. Okay. How many miles does he run on the 19th? Okay, so let's keep track of things here. So on the 18th, let's just draw a little picture here. So on the 18th, all right, he runs 7.6 miles. And then so on the 19th, and then 20th here, and so on. Okay, on the 20th, from the 18th to the 19th, he's going to increase it by 0.2 of a mile. So that's going to be an increase, all right, plus 0.2 of a mile. So that's got to be 7.8. So 7.6 plus 0.2, 7.8 miles now. And again, this is miles, not minutes. Okay, and then what does he run on the 22nd? Well, let's visualize this. So from the 20th, 21st, 22nd. Okay, how many times do you have to add the rate of change? So So here it's plus 2/10, plus 2/10, and again plus 2/10. We're adding 2/10 of a mile. Okay, again, that's rate of change right here, which in arithmetic sequences is called the common difference. So you'd have to add that 4 times. So what do we do? So from the 18th to the 22nd, so we start off on the 18th here at 7.6 miles plus, right, 4 times the 2/10 here. So that would be 7 point, well, not 7.6, 7.8, or excuse me, not 7.8, 7.6 plus, so 0.8, and that would give you, about 8.4 miles. So 8.4 miles right there. And then what does he have on the, how many, or how far does he run on the 15th? Well, we got to go back in time. So to go back in time, that's from the 18th, all right, to the 17th, to the 16th, to the 15th. So you got to go back in time, and that means you're going to be subtracting the rate of change. So minus 2/10. So minus 2/10, or minus 2/10 again. So minus 2/10. So you got to multiply that by 3. So we're going to use the 7.6. So 7.6 minus 3 times the rate of change, because we're going backwards in the sequence. So 7.6 minus 0.6, that'd be 7 miles in total. And then it says write a rule that gives the number of miles that David runs on the nth day. Okay, so let's bring in the sequence function again. So a sub n, let's put this in red here. A sub n is equal to the first plus the common difference times n minus 1. And we need to know what's on the first. Like, how do you get back from the 18th to the 1st? So let's find a sub 1 here. Find a sub 1, which is on July 1st. So we know in the beginning that he runs 7.6 miles on the 18th. So from the 18th to the 1st, going backwards. So here we take 7.6 minus how many days? So from the 18th to the 1st is 17 days. So 17, right, times the 2/10. That's 7.6 minus 3.4, and that'd be 4.2 miles, okay, on July 1st. On July 1st. Okay, so then what do we have? So let's, we know that's the first term, so here in general, so a sub n is equal to 4.2 plus the common difference, or the rate of change, which is 0.2 times n minus 1. There's our sequence formula. And if you want to simplify this, I'm just going to bring it down here to simplify it. The formula would be a sub n is equal to 4.2 plus 0.2 times n minus 0.2. 4/2 minus 0.2, that's obviously 4. So our simplified formula would be 4 plus 0.2 n. Okay, simplified. And there we go. There's our sequence formula there for the situation. Okay, and then so this is the formula for the nth, for how much mileage he runs on the nth day. All right, so let's kind of summarize everything that we were talking about. We're dealing with arithmetic sequences here, sequences that use addition. Use addition to generate the terms. Okay, you can think of it as additive sequences. Okay, so what do we know? What did we go over? We went over the function rule, which is called the explicit rule. So just giving you the math lingo here. So the function rule or the explicit rule for this in the sequence notation, where we have a sequence that looks like this: a sub 1, a sub 2, a sub 3, comma, a sub 4. These are the terms, all the way to the last term of the sequence, which is a sub n. And to get any term of the sequence, we call that a sub n in the general, which represents your last term here. And this represents your first term. And this is the second one, and so on. A sub n is equal to your first term, a sub 1, plus some common difference, which is the same as the rate of change, ROC, times n minus 1. And then if you want to also rewrite, you can also express it in terms of the zero term. If you simplify this and redo a problem, you could express it in terms of a sub 0, and that would be a sub 0 plus d times n. So I'm going to put a big or here. You can use either formula, where a sub n is the nth term or the last term. So a sub n is your last term in the sequence. N is the number of term or the term number. Number of terms or term number. And D, okay, it's the same thing as the rate of change, but in sequences is called the common difference. Okay, the other thing that we learned was how to find the average. Okay, so let's talk about that for a moment. So to calculate the average or middle number, middle or median number, you can think of it either way. By what you do is you take the first term and add it to your last term and simply divide it by 2. Okay, so in words, it's first plus last, divide that by 2. And then to use the average, okay, to calculate the total sum of terms, you simply take your average and you multiply it by the number of terms. Which, if you want to write a formula, it'd be a sub 1 plus a sub n, divide that by 2, all right, times n. There we go. And then all you have to do is get good at it, okay? And that, my friends, requires you to be in class, okay? Because what we do is we develop all this together, all right? And then we do some practice, we do some warm-ups, we do all sorts of things. We do the check for understanding, and then we go from there, okay? All right, I'm going to end the video here, and then I will see you in class. You guys take care.